Good evening, friends. Welcome to 360 TMG Domain Analytics, and currently we are dealing with neural networks and its applications in pharma analytics. So yesterday we have seen different topics related to pharma analytics. So the agenda what we have dealt yesterday was like we have seen neural networks in pharma industry, neural network primer, and we have seen what is perceptron and multi-layered perceptron algorithms, and what are different activation functions, and what is error surface and gradient descent algorithm. So we have several applications we are using with neural networks in pharma industry, such as drug design, optimization of pharmaceutics and formulas, in vitro, in vivo correlations, and identifying underlying relationships, genomics and proteomics, pharmacokinetics, and disease diagnosis. So we have seen all these different topics yesterday. So how we are dealing with perceptron, and what is the calculations we have in neuron, and what is a multi-layer perceptron, and what is activation function, error surface, gradient descent algorithm. So let us recollect a few points that we have discussed yesterday. So as I have said, there are several advantages when we consider with neural networks algorithm in pharmaceutical industry. There we have already seen that there are several different domain topics that are being connected with the pharmaceutical industry, such as genomics, pharmacokinetics, disease diagnosis, etc. So there are several advantages of neural networks, such as parallel processing capability, storing data on the entire network, capability to work with incomplete knowledge, and having a memory distribution. So these are the different advantages. So yesterday we have seen the difference between biological neural network and artificial neural network. So we know that the basic building blocks of neural network are neurons, weights, and activation function. Okay, so when we take in case of biological neural network, we have dendrites. Okay, so we have dendrites. So we have a network of dendrites, and these are connected to a cell nucleus. Okay, and when we are giving our inputs, okay, and these inputs are given with synapses. So each input will be given by adding some synapses. So this is the basic structure what we have in our biological neural network. Okay, so what is happening? So we have taken this same structure and we are trying to mimic this. So in our case, the inputs are nothing. So we have taken inputs as dendrites, and the X1, whatever we are seeing it as a node, and the synapses is nothing but it's a weight. So yesterday we have seen that weights will be added with bias in the process, right? And this cell nucleus is nothing but output. So from here, these are connected to a output resource, which is nothing but axon. Okay, and in our case, artificial neural network, axon is output. So this is the basic comparison what we have, and we have seen how biological neural network and artificial neural network works. So we have seen few more points yesterday, such as neural networks are a part of deep learning, which comes under comprehensive term known as artificial intelligence. And in case of artificial neural network, it is a computational model that consists of several processing elements that receive inputs and deliver outputs based on their predefined activation functions. So we have two different types in it when it comes to different data. So in case of image processing, we use convolutional neural network, where it is a type of artificial neural network that is used in image recognition and processing that is specifically designed to process pixel data. When it comes to recurrent neural network, so it is a type of neural network where the output from the previous step is fed as input to the current step. So RNNs are mainly used for sequence classification and sentiment classification and video classification processes. So sequence labeling, so the part of speech tagging and named entity recognition are part of recurrent neural networks. And so we have the artificial neural network consists of three parts. One is input layer, the second is hidden layer, and we have output layer. So there can be number of hidden layers we can take based on our requirement. So what is input layer? Input layer is nothing but it accepts inputs in several different formats. And when it comes to hidden layer, it performs all calculations to find hidden features and patterns in our data. And finally, we have output layer. The input goes through a series of transformations through hidden layers, and which finally results in output that is conveyed using this. So we have input layer, okay, and we have hidden layers, and finally we have output layer. Okay, so this is the basic structure what we have in artificial neural network. So when it comes to, so the association between neurons outputs and neuron inputs can be viewed as the directed edges with weights. So we have seen along with our inputs, we provide some weights, okay, and we will have some bias value, which is 1, okay. So the association between neuron outputs and neuron inputs can be viewed as directed edges with weights. So each of the input is multiplied by its corresponding weights, and weighted sum of inputs, and it includes the bias. Okay, this we have seen. So weights normally represent the strength of the interconnection between neurons inside the artificial neural network. So that is a function of weights. So why we are adding weights? Weights normally represent the strength of interconnection between neurons. So that are present in our neural network. So we have different neurons in our neural network, right? So what weights does? It represents the strength of interconnection between these neurons. And what happens in this process is, if the weighted sum is equal to 0, then the bias is added to make the output as non-zero, or something else to scale up to the system's response. Okay. So why we are using bias? So when the weighted sum is equal to 0, we are adding bias to make the output non-zero or something else to scale up the system's response. Bias has the same input and weight equals to 1. So here the total of weighted inputs can be in the range of 0 to positive infinity. So yesterday we have seen what is activation function, right? Activation function decides whether a neuron should be activated or not by calculating the weighted sum and further adding bias with it. So that we have seen. The purpose of the activation function is to introduce non-linearity into the output of the neuron. So in this case, we have different types of activation functions we have. So the first one what we have is linear function. Okay. So in linear function, what happens is a straight line function, which is linear function is nothing but a straight line function where activation is proportional to input. Okay. So which is the weighted sum from neuron? So what are the pros? So what are the pros we have with linear activation function? So it gives a range of activations. So it is not binary activation. So we can definitely connect a few neurons together, and if more than one fires, we could take the max and decide based on it. Okay. So this is the purpose of linear activation function. And we have one more activation function, that is ELU. Okay, so we can see here we have ELU. So in this case, this is nothing but exponential linear unit. So ELU, it is nothing but exponential linear unit. Okay, so it is widely known as ELU, and it is a function that tend to converge cost to zero faster and produce more accurate results. So different to other activation functions, ELU has an extra alpha constant, which should be a positive number. Okay, so that is ELU function. ELU function is nothing but exponential linear unit. So the next function what we have is ReLU. So which is nothing but ReLU, and it is known as ReLU. So what is ReLU? A recent invention which stands for rectified linear unit. So ReLU stands for rectified linear unit. So the formula is deceptively simple, so that we can see here. So despite its name and appearance, it's not linear, and it provides the same benefits as we have in sigmoid function. So we will see what is sigmoid function. Okay, so the function is more or less similar to sigmoid function. So next we have one more activation function, that is nothing but leaky ReLU. Okay, so leaky ReLU is a variant of ReLU. So we have seen what is ReLU. So leaky ReLU is a variant of ReLU. So instead of being zero, okay, a leaky ReLU allows a small non-zero constant gradient. However, the consistency of the benefit across task is presently unclear. So we are not using much leaky ReLU. Most of the cases we use ReLU and sigma. So we have seen that the ReLU function is mostly similar to sigmoid, right? So what is sigmoid activation function? Sigmoid takes a real value as input and outputs another value between 0 to 1. So the value will be between 0 to 1. It is easy to work with and has all nice properties of activation functions. So it's a non-linear, continuously differentiable, and monotonic, and has a fixed output range. Okay, so sigmoid is mostly used. And we have one more activation function, that is tanh. So tanh is nothing but tanh passes a real valued number to the range between -1 and 1. So what we have seen in case of sigmoid is it ranges between 0 to 1, right? So here it ranges between -1 and 1. And it's non-linear, but unlike sigmoid, its output is zero center. So that is the difference. So therefore, in practice, the tan H non-linearity is always preferred to the sigmoid non-linearity. So these are the different activation functions we have. So one more function what we have is softmax. So what is we have softmax. So what is softmax? So softmax function calculates the probabilities distribution of the event over n different events. Okay, so it calculates the probabilities different distribution over n different events, and in general way of saying, this function will calculate the probabilities of each target class over all possible target classes whatever we are using. So later the calculated probabilities will be helpful for determining the target class for the given outputs. Okay, so these are all different functions we are going to use in our hypertuning. So this is about activation function and what are the different activation functions we have. So we have seen what is gradient descent algorithm. Okay, so gradient descent is an iterative first order optimization algorithm used to find a local minimum or maximum of a given function. So this method is commonly used in machine learning and deep learning processes to minimize a cost or loss function. So what is gradient? So let us see what is gradient. So we have gradient descent, right? So what is gradient? So a gradient measures how much the output of a function changes if you change the inputs a little bit. So if you are so what does a gradient does is, so it measures the output of a function. Okay, so how much it is changing when you are using the inputs, when we are changing input a little. So what we are doing, we are having our input and we are adding some weights and we are adding our bias, right? And what we are doing, but we are adding some learning rate. So it measures what is happening after this. Okay, that is gradient. And later the calculated. So when we calculate and we find what are the changes, it is a simple measure the change in all weights with regard to the change in error. So you can also think of gradient as the slope of a function. So here we can see. So gradient is slope of a function. Here we can see the gradient. So this is the measure what we are doing. So we have added some initial weight. Okay. And what is happening in this case? So how it is moving. So as we have seen, what is gradient descent? Gradient descent can be thought of climbing down to the bottom of the valley, right? It is moving towards the bottom instead of climbing up to the hill. So how this is moving, it is moving either upwards or downwards. So what is the change that is happening after the change that we have brought to our initial base? Okay. And what happens? This is because it is a minimization algorithm that minimizes a given function, which is nothing but activation function. So we have seen what are different activation functions, right? We are adding activation function during the calculation. So in this case, what we have two different types actually. So one is exploding gradient we have. And one is vanishing gradient. Okay. So what is exploding gradient? So these are different. So we have seen what is the error surface, right? So in error surface, we have two different error points. Okay. So one is exploding gradient and one is vanishing gradient. So while training an RNN method, for an example, if you see exponential growing, okay, if it is very large, so the error gradients which accumulate and result in very large updates to neural network model weights during the training. Okay, so they are known as exploding gradients. At an extreme, the values of weights can become so large as to overflow and result in NAN values. So this is what happens when the gradients have increased. So what happens in vanishing gradient? So in this case, while we are training RNN model, your slope can become either too small. This makes the training difficult. Okay, when your slope becomes too small, it becomes very difficult. Okay, training your model, it becomes difficult. And when the slope is too small, the problem is known as vanishing gradient. So these are two errors what we have. Okay, so these are two errors what we have that we have to come across during neural network process. Okay. So now we have seen different points where we have seen the advantages of neural networks algorithm in pharmaceutical industry. So there are several advantages, right? Now we are going to see a user use case where we have tried to do the disease diagnosis. Okay. So we have used some patient data and we have tried to class to predict. So we have tried to predict the patient information from this data. And yeah, we have seen what are the different advantages of neural networks. So, as I have explained yesterday, so based on different characteristic attributes, patients will be classified according to varying degrees of coronary artery disease. Okay, so this is nothing but blockage of arteries. So if it is not recognized at particular stage, so it is very lethal. It leads to heart attacks. Okay, so now we are conducting. So now we are using some neural network technique, artificial neural network technique. So to recognize the heart disease using the patient data. So we have taken this data. We have taken some records of 1024 patients from 3 different hospitals, and the whole data contributes 76 attributes, but based on the previous research and results, we have taken 14 attributes for the testing. So let us run the program and see how it works and different in different cases. So we have taken the file. Actually, today also we have given a question for you. So please answer the question. The link will be posted in your chat box. So please click on the link and answer the question that is related to our neural networks. So I am using Google Colab to access my file. So I am uploading my file. So here we have the problem statement what we are working on. So I have taken my file in Google Colab. Okay, so here I have the data. So the problem statement what I have is like the medical test results were conducted for coronary artery disease prediction, and the studies have shown that individuals with certain medical test results are at higher risk of coronary heart disease. And if the condition is not analyzed or detected on time, it could be lethal to patients. Okay. And there are several risk factors that could lead us to detect the varying degrees of coronary artery disease, such as blood pressure, cholesterol levels, heart rate, etc. So all these details are being taken in our data set. So what happens? The problems with detection of coronary artery disease, because as we have the coronary artery disease often develops over decades, it can go virtually unnoticed until a complete blockage of the artery produces a heart attack. So these are the problems what we have with if we haven't detected the disease on time. So what we are going to do? So the hospital or organization wants to find an alternative solution for this problem, which could help them to detect coronary artery disease, and by change of lifestyle, this could be reverted. So we have the data of historical data, and we are going to work on this data, and based on the results, we can prescribe to the patient on changing the lifestyle, and maybe this condition could be reverted. So that is the problem statement what we have. So we have started with data preparation. So we have understood we have started with business understanding and data understanding. So we have done some data preparation. Then we have done model building using our machine learning model neural networks, and we have done evaluation and deployment and monitoring. So what is the objective of this analysis? So the objective is to minimize the risk of patients or maximize the convenience of doctors in assisting their patients. And what are the constraints we have? So the disease develops slowly and increases risks. So the correlation between the different attributes are really less. So what we have here, so in research, we have the historical data of a patients who have undergone tests for coronary heart disease were taken, and the risk factors were analyzed to predict coronary heart disease. So the proposed plan was to, the coronary heart disease data is a part of the study wherein the aim is to study how risk factors differ from patient to patient, depending on other factors such as age, gender, etc. So what are the benefits? So the benefits that we have listed here is like, is there a simple yet reasonable, accurate way to predict the coronary heart disease? Or we can analyze based on historical data. So is it easily available? Is the risk, is it risk free or inexpensive? So these are the different factors that were considered when we have taken this data set, and when we are using this data set for neural network analytics. So the data was collected from different hospitals and the data is related to 1024 patients. Okay, these are the records of 1024 patients. So we have used different Python libraries such as pandas, numpy, matplotlib, and further for the machine learning side of this project, we have taken sklearn and keras. We have imported libraries such as so we have imported these libraries for doing this analysis. So we have imported all the modules whatever required for this process. So this is the file, this is the data file what we have. So we have uploaded our file. So I have run the complete file. So here we have started with seeing some data. Okay, what we have here. So we have data such as age and other details and how the data looks like. So this is the shape. So we have 1025 records and 14 attributes. So we have seen that what are the different data types we have in our data. So we have taken some sample data to check what it is. So we have taken some elements records from 280 to the end. So here we can see that there are these are the data set. This is the data set with what we have. And we have actually we have tried to remove some missing data if it is there any missing data in our data. So this is part of our EDA and data preparation process. In the same way, we have checked for NaN values. So again, we have checked for data types. Then we have done some descriptive analysis where we have found the minimum age is 29 and maximum age is 77. So these are these are some details what we have found in our descriptive analysis. So we have done some graphical representation over here. So we have plotted some histogram for each data. So we can see the age. Okay, age data we have so how the values are increasing. So we have compared this with our target. So here we are seeing the frequency of the age. Okay, the heart disease frequency for different ages what we have. So here we have the target variable. So if it is if the person is so we are checking if the prediction is yes and prediction is no. Okay, that we are looking here. So this heat map represents the variance. So we are looking at the correlation part. So the maximum correlation was 1 and minimum correlation was minus 0.4 And here we can see in some cases we can see 0.4 correlation was available and not more than that. So they are not much correlated data. This data is not much correlated. Then we have plotted to check different factors that we have compared with age. So how they are taking with age. Here we have we have taken the training and testing data sets. So here we have taken 80% of the total data as a training data set and 20% of data as testing data set. So in this process, we have tried to do the analysis for categorical process and binary model also. So here we have converted some data to categorical labels. So building and training the neural network was the major networking and neural network analysis what we are looking into. So now we have our data fully processed and we have split the data into training and testing data sets. So we can begin building a neural network model to solve this classification problem what we are looking at. So here we have used Keras, where we will define a simple neural network with one hidden layer. So that is the beginning method what we have done. Since this is a categorical classification problem, we will also use softmax activation function in the final layer of our network, and a categorical cross entropy loss during our training phase will be noticed. So we have installed TensorFlow. So we have imported some more files such as Keras, sequential, dense, and we have imported some optimizers such as Adam. So we have defined function one function such as create model to build Keras model. So here we can see we have used different functions and dropout functions to create this model known as sequential. So total parameters we have 378 parameters we have used, and the trainable parameters are 378, and the non-trainable parameters what we have is 0. So we had 50 epochs. So we are here trying to fit the model to our training data first. So when we have taken, so the parameters what we have given is like, so we have taken epochs to be 50 and the batch we have fixed as 10. So we can see here the loss function we have, the accuracy is being calculated, the validation loss is being calculated, and validation accuracy is being calculated. So the final, after completing 50 epochs, here we are seeing different values here. So what we have done is, so here we have our results, and we have tried to plot the number of epochs, and we have tried to compare with accuracy. So as we are seeing here, the epochs are increasing. We have compared the test and train data, and the results and the accuracy was increasing with increasing number of epochs, right? So we are using our neural network where the weights are being added and learning rate is being added and the error is being reduced. Okay. So here we can clearly see the difference that starting from the epoch 0, when it reached epoch 50, the accuracy has almost reached to 0.90. So in the same way, we have plotted for losses also. So how the loss function is going on here? So we have compared train and test, and the loss was decreasing tremendously as the number of epochs are increasing. So to improve certain results. So although we achieved promising results, we still have a fairly large error what we are seeing in our process. So this could be because it is very difficult to distinguish between the different severity levels of heart disease. So we have taken different classes like 1 to 4. So here we can simplify the problem by converting the data into binary classification. So we have done that, like we have taken only two values, heart disease and no heart disease, only two values, and now we are trying to look into the data again. So here we have only two values here, 0, 1. So before case, what we have done is like we have taken different categorical values where we have taken 4 different classes, and we have tried to classify that, and then we have tried to predict it. But now what we are doing is like we are taking a binary classification problem, and we have taken only two values here, that as heart disease and no heart disease, which is represented as 0 and 1. So we have repeated the process. We have done the Keras model. We have used Keras model for binary classification, and we have fit the model, binary model, to our data, training data. So after completion of our data, here we can see the accuracy is 0.90. So these are the values we have compared, and these are the values what we have. But when we have done with this data, when we have used the categorical process and categorical values, so the results were different. So that we can see here in our table, where we have compared the two models what we have used. So here we have the results for two different models what we have used. So there is not much difference, but we can see here the results for categorical model, the accuracy what we have achieved is 0.89%, and for binary model we have achieved the accuracy as 0.90. Okay, and the precision, recall, F1 score, and support we can compare with binary model, which are almost the same, and the differences are really less. So these are the two models what we have done to predict our heart disease. So in this case, we have seen different categories. We have taken into different categories, like 4 different classes we have taken our results in 4 different classes. And in case of the second case, binary case, we have taken like heart disease and no heart disease, only 2 values, and we have tried to find our prediction. And the accuracy was achieved more in case of binary model. So this is the use case what we have used for neural network analysis. And we have tried using 2 different models with 2 different types of output data, and we have tried to compare these 2 models. So we have seen what are neural networks and what are the different advantages we have in pharmaceutical industry. And we have seen in general what are the advantages of neural networks today. such as the advantages we have, such as parallel processing capabilities we have, storing data on the entire network, capability to work with incomplete knowledge, having a memory distribution. These are all different advantages what we have with neural networks. And we have seen that neural networks is a part of deep learning and it is also known as artificial intelligence. An artificial neural network is a computational model that consists of several processing elements that receive inputs and deliver outputs based on their predefined activation functions. We have two other models, neural network algorithms we have, where in case of convolutional neural networks, we use image classification, image recognition, we use convolutional neural networks. In case of recurrent neural networks, the different applications we have such as video classification, sentiment classification, and we use this for speech tagging and named entity recognition also. So we have seen that artificial neural network consists of three different parts: input layer, hidden layer, and output layer. And we have seen what is an input layer, hidden layer, and output layer, and how the the association between the neuron outputs and neuron inputs can be viewed by weights, whatever we have. And we have seen the weights are normally representing the strength of interconnection between different neurons and how they are represented. So we have seen what are the different activation functions we have. We have seen different error functions what we have, and we have seen different gradient descent algorithm, how it is affected. So this is our neural networks in pharma analytics. So we have seen different topics in neural networks in pharma analytics, and we have tried to analyze using one use case where we have tried to predict the heart disease in our case. So thank you everybody for participating in our domain analytics pharma in specifically pharma analytics program, and we have seen all different machine learning models what we have in this session what we had for this last week. And thank you everybody for participating in this, and I hope you have answered your question that is posted in your link. Please answer that question, so you can click that link, and that is a multiple choice question, and we request you to answer that question. Thank you, friends. Let us meet in our next domain analytics program, and we look forward that you are going to attend the domain analytics next program also.